Okay, hi. Today we have an example of a steady state mass balance. Steady state means that it is a time-independent process. So it is continuous inflow and a continuous outflow. Well, we have an example of a vessel filled with salt. The concentration in this vessel, which is initially S0, is well mixed. So the concentration in the whole vessel is everywhere the same. At a certain moment, we start to flow in a liquid containing a concentration, let's say CS in. And at the outlet we have a concentration CS out. But we want to know the steady state concentration, so this is equal to the steady state concentration. Well, how can we solve this problem? Well, the basic idea is to set up a mass balance over the salt. So let's write down the mass balance of the salt. That's the amount of salt which is changing in the vessel is equal to the amount which enters the vessel minus the amount which leaves the vessel. But this is a steady state problem, so this term is equal to 0. So that means 0 is, well, how much salt is entering the vessel? Well, we have seen here that's the product of the volume flow rate and the concentration. So that's the volume flow rate multiplied by the concentration at the inlet minus the flow rate multiplied by the concentration in the outlet. But you now immediately see that the concentration under steady state conditions is equal to the one which enters the vessel. Is this a surprising result? No, because imagine you are entering here a concentration and you wait infinite long, then at a certain long time you have here the same concentration as at the inlet. Well, in the example we took a concentration of 1 gram in the entrance and 5 gram initially in the vessel. Well, the answer is of course that the steady state concentration is equal to the concentration at the inlet. That means 1 gram per liter. Hope that you get a little bit more feeling about what steady state means.